everyone. Today I'll be covering related rates. To solve related rates problems, you first identify variables and constants, write an equation relating them, differentiate with respect to time, and then finally substitute in known values to solve. Here's an example with a moving object. Pause the video and read the problem. Firstly, we can draw a diagram representing our situation, with x to represent the distance from the lamppost and s to represent shadow length. Then we can use a proportion and solve for the relationship between our variables. Then we differentiate and then plug in 4 for dx over dt, as that's the rate of change of the distance from the lamppost, to solve for ds over dt, or the rate at which our shadow is increasing. Then, with two moving objects, here's an example problem. First, for part A, we can use Pythagorean theorem to get a relation between all our three variables. Then we solve for z when x is equals to 4 and y is equal to 3. Differentiating our original expression gives us this, and then since we have dx over dt, dy over dt, dz over dt, and x, y, and z, either given by the problem or solved for, we can find dz over dt, or the rate of change of distance between the two ships. For part B, we can start with tan theta is equal to y over x, and then we differentiate. After that, since we have all our known values, we can get the rate of change of theta as 3.4 radians per hour. Here's a problem with filling a tank. Pause the video and read the problem. Since our tank dimensions are given in feet, but our rate of volume change is given in gallons, we need to convert it to feet cubed per minute. After that, knowing that our r is directly proportional to h by a scale factor of 1, we can replace r squared by h squared to get an expression for volume in one variable. After that, we differentiate with respect to time and then isolate dh over dt. Then we define the height when after we've poured in water for 10 minutes. And using that value, we substitute in our original expression for dh over dt and then get 0.167 feet per minute. Thank you guys for watching.